For decades, there's been this one story that's kind of defined the entire tech landscape.
The classic myth, right?
Exactly, the garage startup. 2 people, a couple of laptops, a brilliant idea scribbled on a whiteboard.
And that was supposed to be enough. That was the great equalizer, where pure ingenuity could take on the giants.
And for a long time, in the software era, that was, well, it was largely true. The barriers were low.
They really were. Capital wasn't the main obstacle if you had the talent.
But today, we're here to deliver a pretty stark reality check. We've been digging into sources analyzing the current AI landscape, and it seems the garage is functionally dead.
That's the core thesis. The sources we're analyzing today make a really compelling case that AI is not another capital-light software business.
It's something else entirely.
It's a heavy industry. It's defined by what they're calling an economy of scarcity. And our mission today is to unpack how this happened and who the new, call them gatekeepers, are.
The ones who own the factories of intelligence. And look, as we guide you through this, we really want you to be part of the conversation. If you find this stuff valuable,
And we hope you do.
then please hit that subscribe button, give us a like, and definitely share this deep dive with anyone else who's curious about where all of this is heading.
Your support really helps us keep doing this. Okay, let's get into it.
Right, so let's start with this first big idea, the end of the open frontier. I mean, think back just 10 years ago.
Not even that long.
If you wanted to start a software company, what did you need? A developer's salary, basically. You could rent some cloud space for, what, a few $100 a month?
And you could scale to millions of users on that model. The marginal cost was incredibly low.
That was the open frontier.
Yeah.
But AI, you're saying, it has just changed the fundamental physics of all of that.
It really has. It's introduced this economy of scarcity. And we're not talking about a scarcity of ideas or talent. We're talking about a scarcity of something physical.
Compute power.
The raw brute force compute needed to create these massive foundation models.
So what is the actual barrier here? Why can't a small, brilliant team build the next big foundation model from scratch?
It boils down to one thing, really: the training bill.
A training bill, okay.
The sheer scale of these models means you need enormous amounts of computational power running, 247 for months on end. And the cost for a state-of-the-art model, the sources say it starts in the hundreds of millions of dollars. Starts. And it's already on a path to $1 billion for one training run.
Wow. Okay, so that financial wall it changes everything. It immediately limits the players to, what, a handful of global entities?
Exactly. And that has immediate, very real consequences for innovation. The first thing to go is independence.
What do you mean by that?
Well, most startups in this space simply can't afford that kind of compute. So what do? They get tethered to a giant.
Tethered. And what does that look like?
It's an exchange. The startup trades equity, a piece of their company, sometimes a big piece for compute credits from one of the huge cloud providers.
So they're not customers anymore, they're partners.
Right. You could call them that. But really, it effectively turns them into outsourced research arms for the big platforms. The giant gets R&D without the risk. And the startup gives up a huge chunk of its autonomy before it even gets started.
That is a profoundly different model. The infrastructure provider is basically buying a stake in their own customers.
It summarizes the whole shift perfectly. The takeaway here is that AI is not a capital-light business. We have to stop thinking about it like app development.
And start thinking of it like what?
Like a heavy industry,
Yeah.
like oil refining or semiconductor manufacturing. It's defined by these massive, fixed, upfront capital investments.
Why the oil refining analogy? That seems intense.
Because you need a huge, expensive, specialized factory, the data center, the compute cluster, before you can produce a single drop of the final product.
Which is the trained model, refined intelligence.
Exactly. The cost isn't in the code anymore. It's in the physical means of production. You need immense capital just to build the factory.
And that capital belongs to a very, very small club. So if money is the first wall, how do they protect their position? That brings us to section 2. Vertical integration.
Yeah.
From sand to software.
Right. This is a key strategy. You can't just own one piece of the puzzle. The dominant players are controlling the entire stack through intense vertical integration. There are really 3 pillars to this.
Okay, pillar number 1.
It starts with the hardware, custom silicone design. Historically, even the biggest companies would buy their chips from external vendors.
But not anymore.
Not for AI. Now they're designing their own specialized chips. You see things like dedicated tensor processors, inferential accelerators, all these custom designs tailored exactly to their own software frameworks.
Why is that so important? I mean, can't you just buy powerful chips off the shelf?
You can, but this gives them a massive edge. First, optimization. Their software runs faster and more efficiently on their own hardware. That means their training costs are lower.
Cheaper for them to build.
And cheaper for them to run. The second advantage is speed. They don't have to wait for the market. They can build a chip for exactly what they need, right when they need it. It creates this feedback loop that just accelerates their development way past anyone else.
So they build the best engine, and then they make sure everyone has to drive on their road. That sounds like the second pillar.
That's a perfect way to put it. The second pillar is controlling the funnels. They own the cloud platforms.
The places where everyone else has to go to deploy their models.
Absolutely. No matter how amazing your application is, if you want to reach a global audience, you have to deploy it on their infrastructure. You have to pay them rent.
It's a mandatory toll road.
Precisely. And this guarantees a constant revenue stream flows back to them no matter what. Plus, it creates incredible lock-in. Once your entire system is built on their tools and their custom chips, moving away is almost impossible.
That's a powerful combination. But the third pillar you mentioned, it sounds even more fundamental, energy.
This is the ultimate barrier. It's what really turns this from a tech business into an infrastructure business. We're not talking about powering a server room.
We're talking about powering a small city.
That's what the sources say. Building one of these major AI data centers requires securing that level of energy reliably.
So these aren't just IT companies anymore.
No. They've become utility-scale energy players. Only a handful of entities on the planet have balance sheets big enough to buy a nuclear power plant or to sign a 20-year energy contract to guarantee that power. The sources are clear. This battle for the gigawatt is foundational. If you can't secure the energy, you can't compete.
This level of concentration, it really reshapes the entire tech world. Which brings us to Section 3, this idea of a tenant economy. You have to ask yourself, and you, the listener, should think about this, which side of this new divide does my company or my idea fall on?
And the divide is sharp. It's defined by who owns the resources. On one side, you have the builders.
The ones who own the compute, the energy, the models.
Yes. They own the factories. They control the flow of intelligence itself.
And on the other side,
you have the tenants. And there are thousands of them. Startups, big companies, all innovating, all building amazing things, but they're building wrappers or applications on top of the builder's APIs. They are completely dependent on the factory.
So is this necessarily a bad thing? I mean, the tenants are still innovating. They're solving real problems for people.
It's not that innovation stops. It's just that it becomes structurally limited. A tenant's fate is completely tied to the builder's policies.
Pricing, for example.
Pricing, rate limits, platform changes. And the biggest risk of all, the builder can decide at any moment to just build your feature into their core model.
And your entire business model disappears overnight.
Instantly undermined. And this reliance means tenants are effectively paying a perpetual royalty. It's a tax on intelligence. Every single token your application uses, whether it's for an internal process or a customer, a piece of that revenue flows directly back to the infrastructure owner. It's a guaranteed royalty for the owners of this new heavy industry.
That's a huge shift in corporate structure, but we have to zoom out now. Because this isn't just about business. This gets into geopolitics. Let's move to Section 4. The geopolitical stakes.
Yeah, this is critical. The sources don't just frame this as an antitrust issue. They frame it as a matter of national sovereignty.
Which makes sense.
Yeah.
If these AI models are the new engines of the 21st century, driving everything from the economy to national security.
Then the question of who owns those engines becomes the most important question of all.
Right. If they're all owned by a handful of companies in one or two countries, what does that mean for everyone else?
It creates a massive dependency, a fundamental risk. How can you be a sovereign nation if the core intelligence that runs your country's critical systems is controlled by an external entity?
So how are other nations responding to this?
They're scrambling. We're seeing this huge push for what they're calling sovereign AI clouds.
Government-funded infrastructure.
Exactly. Heavily subsidized projects to build domestic AI clouds for their own industries to try and avoid that total dependency on a few overseas giants.
But can they even compete? Based on everything we've just discussed, the scale required is just monumental.
And that's the core challenge they're all facing. The oligopoly has a massive head start. We're talking hundreds of billions already invested. They've secured the energy deals. They have the chip pipelines. For most individual nations, matching that scale is, well, it's proving to be almost impossible.
So to summarize where this deep dive has taken us, the AI revolution is real. The sources all agree on that. But it's not democratic.
Not at all. That open frontier of the internet, it's been replaced by a gated landscape. And the gates are controlled by the people who own the physical means of production.
The chips, the data centers, the power plants.
The gatekeepers of the next century, you could argue, have already been established.
So the big question for entrepreneurs isn't, how do I build a better garage anymore?
No. The question is, how do you succeed in a world where the very foundations of intelligence are already owned? Innovation will happen, but it will be tenant innovation. It will rely on the builder's infrastructure.
And that leads to the final thought we want to leave you with, something to really chew on. If innovation becomes completely dependent on this kind of capital-intensive infrastructure, if you need hundreds of millions of dollars just for the training bill, how does a truly disruptive idea, something non-commercial, something radical, something that maybe challenges the very system the builders have created, how does an idea like that ever see the light of day?
That's the tension, isn't it?
It is. Thank you so much for joining us for this deep dive into the infrastructure oligopoly. If you found this valuable, please subscribe right now so you don't miss our next one.
Like this episode, leave a comment with your thoughts. What do you think of this tenant economy?
And share it with your network. Help other people understand the true cost of intelligence. Until next time, keep digging deeper.